we've got a, here's the proof. Here's our given. There's a diagram. There's what we're trying to prove. So all we gotta do is make sure we can connect up these dots. The strategy I keep reminding you guys, if you don't know what else to do, take the diagram, mark everything you know or could find out on the diagram. So for example, in this case, AB is parallel to CD, so those are marked. E is the midpoint of AC and BD. All right, so that means if it's the midpoint of AC, these are congruent. If it's the midpoint of BD, these are congruent. And that's just me taking, excuse me, taking the given and putting them over here. I have lines that intersect. Something I can do with this picture that builds on that idea is to go ahead and mark the vertical angles as congruent. I don't know if that's relevant or not, but I can mark them. If you don't know what else to do, think about the core basic things that we've talked about that apply in all situations regardless of givens. That includes vertical angles. That includes reflexive sides. And on occasion, reflexive angles. There will be times that we have an angle shared between two triangles. So it's a good habit to be in to ask yourself, can I use some of these properties to keep this thing going? Now, if I look at this, I have to come up with 3 things to verify that two triangles are congruent. The triangles I'm going for here are AEB and CED. But, so, do I have that here? Have I got at least 3 things that will verify that fits in with one of the theorems we talked about? What? Yeah, I've got 2 sides and the angle between them. Interesting enough, this given up here, I never even came into play. So when I go to write the actual formal proof now, statements and justifications.
Is at the very end, is your last justification always going to be like SAS or?
If your goal, ladies, is to prove that the 2 triangles are congruent, your last justification will always be which of those 5 theorems did it.
Okay.
So AB parallel to CD, given. E is the midpoint of AC, given. And I'm going to write the follow-up of AE congruent to EC by the definition of midpoint. Now, I'm splitting that given into 2 separate statements in order to better illustrate what's going on. If you were to write this out by saying, just copying this statement verbatim, word for word, right there, and then write the 2 follow-ups from that, that's perfectly fine. It's just it's a little like different twist on the English. It's I can have one bullet point on my outline that's the same bullet point as yours. When we write the paper, we use different words to explain it. What's up?
And BE.
Yes.
Or ED, yeah. Yeah.
E is the midpoint of DB. That's given and correct. I can now say that DE is congruent to EB. So that's 2 out of my 3 statements. If I have a little scoreboard going of what I need to prove, that's 2 of them. Now I can knock out the 3rd statement by pointing out that angle AEB, that's this one right here, is congruent to angle DEC, that's this one right here, by the vertical angle theorem. And what I'm going to, based on the time we're at here, now I can say triangle AEB is congruent to triangle CED, and that's by side angle. Side